Well, thank you very much. My name is Fedor. I'm going to share with you, this is going to be probably the most technical talk here, but hopefully it's going to be interesting. I'm going to share with you the thing we built inside and we thought that maybe it's going to be useful for others. Maybe not, we'll see, hopefully. But and the goal of this adaptive models thing is to scale up ML analytics with human in the loop. And human in the loop is the concept which you hear quite often about, and scaling up analytics is hopefully some of you want. There's a brief story of my work experience. I did some PhD in machine learning, then worked in Amazon in forecasting demand actually for every item Amazon sells, and some personalization in Microsoft and AWS, and finally Toloka. And so the story of the talk is going to be this, is that first I'm actually going to introduce to you the Toloka and the adaptive models, briefly what it is. And then kind of we get a little bit down into the topic of how companies tag their large amounts of data they have. Like you have a lot of text or images, how do you tag them? Overall, what's the usual approach a lot of companies take? Then I'm going to share the details of how what we've built works under the hood slightly. I mean, not every single detail. I'm not going to show you the code today, but just infrastructure. And I'm going to get a little bit into the use cases, which we can cover. Well, the whole idea of Toloka as a company overall is that it provides you with AI solutions based on, for data-related process based on crowdsourcing and data labeling. And if you have certain tasks, maybe a large amount of tasks which you can think about, this is a little abstract, but task can be tag certain data point, or go to a store and take a picture of a shelf, right? These are you can have a lot of those sort of tasks, and you send them to Toloka, and we have this human-in-the-loop process, which is a part of about data labeling, and part about machine learning models which learn from that data labeling, and they're kind of feeding into each other. And as a result, hopefully something good is going to come out to whatever you want. So about the data labeling part, well, the way it works in Toloka is actually slightly different than quite a lot of other data labeling companies. It's a two-sided platform where you have machine learning teams which post tasks, and you have a crowd. And what by crowd, I mean every single person in the world who has internet can go, and you can go to an app and register and execute the tasks. And then the tasks from ML teams are being sent to the crowd for execution. And the crowd is actually quite large. So we have this global crowd which speak 40+ languages, and there's 100+ countries present. And as a result of this, we kind of get two things, right? So we get multilingual coverage. And with the crowd or with the models, which I'm going to talk about, it's important to keep this in mind, because maybe you want to move to a new market, which you don't have any performers in Norway or anybody who speaks Norwegian, right? And all sorts of other tasks. And then another thing you get is scale. And this is important because maybe one day you have 50,000 messages, another day you have 1,000 messages, and it's really very easily scalable to this 50,000 spike one day, because the way it works is that people see the tasks to get executed, and then they start executing them, and you don't have this fixed capacity for execution. Now, what about Toloka adaptive models? Well, Toloka adaptive models automate model retraining and monitoring with human in the loop. And to decipher this phrase, I'm going to actually share with you, how, the concept of what the concept is behind, right? What's the typical process for a data scientist to process data? I mean, you have data, you have a collection of data, then you say, what do I want to know about this data? Like, about every data point, what do I actually want to know? And you can explain how to label data, basically. That's what it is. And then you say, well, I'm actually going to label it. I'm going to gather human data. Then you prepare this for training. You label data. You prepare your data for training. Then you train a model, deploy the model, and finally, bingo, you have this model somewhere hopefully deployed. You can get answers. Now, the problem with this approach, which basically a lot of people take, is that it takes a lot of time. Like, you actually have to spend a lot of time on every single part. Then there is a certain thing that data shifts, data changes over time. And this process doesn't account for this, right? You don't have any, regular retraining or regular updates of whatever you've built. Then there's no model monitoring as well. Maybe the data changed, but you haven't noticed it because you have a model deployed, nobody monitors it, bingo. Finally, like to build this process in a reliable manner, you actually have to know a bit of a thing about machine learning operations, about how models work, how much time they need to respond to certain requests, like to images, to videos, right? And why the hardware fails sometimes to operate on, say, a large scale, because there is certain, parallel processes which are not working very well when you have a spike in requests. And so what we basically did was said, well, the middle part can be somewhat automated. You can have automated training with AutoML inside. You can automated redeploy. This is all it's all can be written by the engineers. And as a result, instead of having all of this long process, now when we have a task for which we want to build a model, we just follow the process of collecting data, explaining how it's going to be labeled, and then just launching these tasks into this adaptive models thing. And that's it. So the reason why this might be interesting is because actually, according to quite a lot of recent surveys, overall this process takes several weeks, sometimes several months for every new model which you're deploying, and we are speeding up that process. So this is introduction about why we built this, why what we do. Maybe now we can get into overall the process of tagging the data, of how you could approach this alternatively. So let's say you have a large collection of data points. In this case, it's text. It could be images. In this case, these are social media because the topic of today's meetup is social media. But it could be reviews or product descriptions or whatever not. And so you want to tag it. And maybe you have certain tags in mind. Like you want to figure out which of these are relevant and which of these are not. Or maybe you want to figure out what's the sentiment. Maybe you want to figure out if this social media message is a feature request or support complaint. And of course, what people do is they hire a person to do this. I mean, you hire a person, and they go and monitor all of this, and then they tag every single thing, or they write some rules for this, and finally it doesn't scale. And then you hire more people. You have 25 people who are processing, 50 people who are processing this every day. And you have to, it turns out, manage those people, check their quality, and hiring those can be expensive. It's not flexible for the demand. And so often you go, okay, well, I'm going to write some rules, and maybe there are some models out there who have been built for this, right? I mean, there's a lot of sentiment analysis models online. You can ping and get responses. But the problem with these is that they're not for you. They have been built on some generic data set, which is not your data set, which basically means two things. One is that even if you do exactly that task, the sentiment analysis task, maybe your data set is quite different than the data set, the Twitter data set they built on, right? Maybe you have a financial news data set. It's entirely different than the Twitter data set. And another thing is that you don't have these models for the tasks. You might not have these models for the tasks you want. Maybe you want to figure out how to your specific product, whether this message is relevant to your specific product. And as a result, this is what you end up with. You hire a data science team who builds this process. But I already mentioned that, with a data science team, the process is long. You need experts. You actually need experts to hire those people. And then those data scientists have to know about machine learning operations. And even then, usually you hire, say, one data scientist. They're not able to build the pipeline in a super reliable manner in a fast way. And so what we're trying to do, of course, is somehow automate this part, right? Which is that the data scientist can, or not even sometimes, less technical person than a data scientist can ping these models automatically and get this customized modeling, which is for you. But then it's not, so it's more flexible, and you have data drifts which are taken care of. And the reason is, you have this part of the data which is being sent to the crowd, right? And so this relabeling and retraining, you take care of the data drifts. Well, of course, it's a little less flexible than the custom internal models because you cannot do all sorts of crazy things with it. But basically, if you think about the cost to launch dimension and accuracy dimension and dimension of human verification and monitoring, I'd say that it's a little somewhere in between. The cheap version, which might not suit for you, might not be suitable because it is generic, and the expensive version of building everything from scratch and just owning everything. And then I talked about the data drift, but the thing is, you may ask me, well, whatever, data drift, my data scientist is going to retrain the model in half a year and it's going to be fine. It turns out very often, you miss out on those moments when the model needs to be retrained. The COVID came, right? Like you have customer reviews on your website for candles. And then the candles are supposed to be scented. And you put a candle, you have some romantic evening with some nice scent coming out of that candle, right? And then you get some reviews which say, oh, candles are crap. They don't have any scent. And then you try to target this, right? You say, oh, well, maybe I choose the wrong provider who actually built, I have a new contract and this new candles provider doesn't provide high quality candles, right? What turns out that after COVID happened, the whole data situation changed, right? And there's many more reviews, oh, there's no scent in these candles. It's not immediate. It's not that it immediately comes to your mind. The COVID started somewhere in China. You see first news, and you're like, data scientist. This is going to be the issue. You go and retrain. This doesn't happen, right? You figure that out in a few months after, and as a result, you haven't followed. There's actually like a bit of a theory about the data drift. There's distribution shift where data changes over time, like an old language to a new language. Then there is train and test skew, where your training data doesn't represent your testing. There is label drift, where basically the details of the task change over time, and you might not notice this. So what's under the hood? As I mentioned, so now we kind of explored how people approach this tagging data problem. What's under the hood there? Well, how do models usually work? The model is a service overall. You have some model which is hosted, and you have a database which to save prediction, and in the input pings you through the API, you get result back. The API pings the model, and the prediction is saved. Now there's an additional task, which is there's this Toloka API for crowd, right? So there is a Toloka project, which is a crowd project, and basically the crowd responds to some of the items in the database without the model. So now you see in the database there are answers from the model and from the crowd, and here you have a human in the loop, right? You have a model on the top, you have data label in the bottom, you have some logos of the technologies we used, just for, I guess, curiosity if you want to build this yourself. And yeah, that's probably the most technical slide I have, so maybe we can pause on this. But the idea is simple, right? You set up a project, which is the data labeling project, which means you explain how to label your data. And then there is a model on the background, which we have. And by having this loop here and here, you basically have the model retrained and re-updated. Yeah. Well, so I'm giving a technical talk to actually emphasize the point that it's not about social media, and it's not only about social media, and it's not about sentiment analysis or something. It can be applied to quite a lot of things, quite a lot of types of data. Here there's, like on the top, there's 3 text data, then there's image moderation or image classification. We even have some sort of language transformer where you can generate product descriptions, generate a text. And there's a few other use cases. Basically, the brief message is that maybe for us, this helps us launch new tagging much faster. Maybe this can be helpful for you as well. And I'm actually going to pass the microphone to our next speaker, who is from the company called Smelter, and they are focused on social media analysis, which uses under the hood what we have built. And for us, if you have any questions, happy to answer. Go to QR code if you want to actually talk in more details, not in this setting. And or go to try the demo, and also happy to share with you how it works or let you try it. Thank you.